Hi everyone, Senan on this side, and in this video we are going to see how to implement deletion at tail in a doubly linked list, right? So we are making this linked list playlist. So in this we have completed the insertion part. We have implemented deletion at head, and this is the deletion at tail. So if you don't know what is going on right now, so be sure to check the series out. But if you know the logic, the concept, we can get on with this. So the question is, or the problem is, we need to implement deletion at tail. Now we have a couple of cases, 3 cases to be exact, and let's see what are those. So first is a null list. So if you have no list at all, and I say that make a deletion at tail, so you have to delete the last node. So if you have a null list, there is nothing to delete, and if there is nothing to delete, you can just directly return nothing, right? Which is null in this case. So that is case 1. Case 2 is where you only have the head, right? So when you only have the head and you are trying to delete the tail, that in a way also means that you are deleting the head as well. And since you're deleting the head, what you have to do is, now since head is going to point to this node 1, and next after deleting this, you would be pointing that head to null. That is case 2. Now case 3, when you have more than one element, so that means your head is intact, right? In this case there is no list. In this case, head is going to change, and in this case, case number 3, head is going to stay intact. So what we have to do is delete this last node, or the nth node in the linked list. And to delete the nth node, I have to reach n-1th node, because only through that I would be able to access this nth node. Okay, so let's say I have reached this node now. Okay, so this arrow is wrong. Okay, so let's say I have reached this node n-1, then what would I do? Now the thing I would do is, first I would try to delete this node. That's one thing. Then since this next node of this node, the next pointer of this node, is pointing to a valid memory location, which is no more actually part of our linked list. So what we have to do is to update this next link of the node n-1 to null, because there is no node here. So this would be now pointing to null. Okay, that is one of the cases. Next is what? Nothing, you're done, because you don't have to worry about anything else. So yep, that's it. You have to delete this and point the next to null in the case of a doubly linked list, because the previous would be deallocated or removed, or not deallocated, but this would be a part of this node. So when we delete this, we don't have to take care of this link, the previous node. So let's write. So we would have a void delete at tail, and what this would take is nothing, because we are deleting at tail. Now if you see the implementation of our doubly linked list class, we have node star head, through which we would always have the access of the head within this class. So I don't have to take that as an argument or a parameter. See, this is the node structure if you are new to this series. So let's get started. So if we have to delete at tail, now first of all we'll check case 1. So let's check case 1, which is if head is equal to null, then you just return, because there is nothing you can actually do. Or a better way to check this, if not head is true, that means if head is null, you return. Now let's check the case 2, right? So for case 1, we just check if head is a null node or not. For case 2, to know that there is only a single node in this list, how do we check that? To check that, what we'll do is I'll check heads next, and if heads next is null, that means we are in case 2, and in this case our head would actually be updated. So the next would be, if head next is equal to null, then what do? I delete the head node, or delete the head node, and what I will do is I'll assign this head to null and then return. As simple as this could get. This is case 1 and case 2. So rather than doing equal to null, I'll just put a not in front of that, and this would do the job. Okay, this is case 1, this is case 2, and let's look at the final case. So I am not trying to do checking anything else. So if either of the cases are 1 and 2, we would return out of this one. So if we are out of these 2 if statements, then I know I'm in case 3. Now the only thing I have to do is to somehow reach this n-1th. So let's try to reach there, and for reaching there we will use a while loop, because I don't know the list's length beforehand, right? So when you don't know how long the loop will go on, you will use a while loop. So for that, I'll take a node star temp, which would be pointing to the head node, and I know head is not null. I also know heads next is not null, because if heads next is null, we would return through this if statement. I know head is not null. I know heads next is also a valid node. Now, while we'll see what condition do we have to put there, but while something, I'll try to jump to the next node. Temp is equal to temps next. Okay, and how long do we do this? Now, how do we check if we are at a node which is the second last node? And to check that, you check if temps next is null or not, right? Because, okay, so I'll just try this. Temp next is not equal to null. So look at this. I know temp is a valid node because it is head in the very first iteration. I know head next is also a valid node because of, if not, we would terminate or we would come out of this function in this if state. So I know temp is a valid node. Temps next is a valid node, right? So temps next would be a valid thing to check, right? We're not trying to ask next of a null node. That is what we're trying to check. So if temps next is not equal to null, I can jump ahead. So let's say if we reach this n-1 node, so temps, this is temp, so temps next is this, and next of that is null. So if that is the case, we would come out of this while loop. So we would reach the n-1th node of the list. Fine. And yep, now what we have to do is first we need to delete the next node of this temp, which is the last node, and then reassign the next pointer. So let's just do that. Delete temps next. So I am deleting what? The last node, and I'll reassign temps next is actually equal to a null node. And after that, I'll just return, because it is a good habit to return even in void. So it's easier for the programmer to understand where are you actually returning. Okay, so let's look at this once more. Let's say you only have two elements. So we need to check if this works or not. So temp is head. I know temps next is a valid node, but temps next is null, because our list only has two elements for the given example. So in that case, we won't go into this while loop at all. And since we won't go into this while loop at all, we would directly jump to this deleting part, and this would delete it properly. Now, one more thing, as we did in this one as well as this one, if I just remove this would also work. And since I only have a single statement in the while loop, I can remove these parentheses. But again, it's a good habit to have parentheses. But for the moment, let's leave that part. Okay, so delete at tail is finished. Fine. We had three cases. Case one, where you have a null list. So in that case, you directly return because there is no node to delete. Case two is that you only have the head. So the tail and the head both will be the same node. And in that case, we have to update the head, because in this case, head would be pointing to this one node. And if I delete this, now my head should point to a null node. After that, in this case, case number 3, where you have more than one element, that means your head would stay intact and the nodes after that, so one of the nodes after that would be deleted. So this is case 2, where you have at least one node and exactly one node, not at least. And in this case, you have more than one node. So that is the function delete at tail. Let's just save this and let's look at this main.cpp. And so this was the thing that we checked in our last video. So rather than delete at head, I'll try delete at tail, and let's just copy paste it a couple of times, and let's just try to compile this and check. Okay, so g++ main control C, g++ main.cpp. Okay, so it is compiling a.exe, and if I run this, see, first after deletion, we had this original linked list. Okay, so when I declared this a DLL object, a constructor was called. Then we inserted 1 to 10 at tail. So this is insertion at tail if you pass the same arguments. So we constructed this 1 to 10 linked list. Then I printed that. Now after deletion, that is the statement. So we are trying to delete, then print, delete, then print, and so on. So first we delete at tail. So we removed this 10. So we have this list only 9 till 9. Then we again deleted it. So we had till 8, then 7, then 6, then 5, then 4, and so on. And then after that, after you returned, this is deallocated. The destructor is called because it goes out of scope, and the memory allocated for this W linked list is deallocated. If I have written the Yep, I have written the destructor. Okay, so that is about not insertion, but that was about the deletion at tail. And in the next video, we'll see how to delete anywhere in the linked list given the position. So that was the video. Hope I was able to explain this to you, and I'll see you in the next video. Bye.